Hello and welcome to class today. How are you doing? Hope you are doing good. Remember, in this classroom, we are all about bringing you to the knowledge that is needed for you to have. And my goal as a tutor is to ensure that you have the right knowledge that will enable you to stand out any test that will be given to you. And I've always said, in any class you'll be having, you must always learn to set your goals. Why am I always repeating this? Your goals gives you what? Focus. And I'll still beg you, always find time to make some research. And feel free to ask me any question, even if it is not academic question. Probably we can just gist. You just tell me some certain things, we crack some jokes, make some storylines just to get the class going. So I am a friend. Don't just take me as a hard teacher. I'm a fun-loving teacher that just want to play with every of my students that I'm teaching. So for those of us that are on board now for this class, I heard that one of you had some kind of little issues in school. Well, after the class, we're going to discuss on that. But now let's go on. We have today a topic that I titled Motion. A topic in physics under mechanics. Motion. We want to look at motion. What is motion? Motion is a change of position with time. Motion is a change of position with time. Please take note, every one of you, ensure that you are following up. Motion is a change of position with time. Simply means if you are probably in school at a moment and probably you are going home, you move from your school to your home. What have happened? You have changed a position. And it has happened in what? In time. You move from home to your school, you have changed a position. From one place to the other is a change of what? Position. But we have 4 types of motion we're going to be looking at. Then when we go further, I'm going to be adding one which we call relative motion. But let's look at the 4 types of motion for every one of us to understand, which is given to us. Number 1, we have what we call the translational motion. The translational motion. We have what we call the circular motion. The circular motion. We have what we call the oscillatory motion. Oscillatory motion. Then we have the 4th one, the random motion. The random motion. Then I will add the 5th one. The 5th one I'm going to add and explain. The 5th one, we look at relative motion. Relative motion. Now let's quickly look at these motions and what it has for us. Mind you, motion is under mechanics. And according to the physics syllabus, you must treat each of these because any examination you are going to be undertaking in your school, either a beginner or advanced, you must have a proper knowledge of what these motions are talking about. What translational motion is dealing with, what circular motion is dealing with, what oscillatory motion is dealing with, what random motion is dealing with, and what relative motion is dealing with. Are we together now? I come back again. We are dealing with what? Motion. And what is motion? Motion is a change in what? Position. You move from one class to another class. You are undergoing what we call motion. But let me stop to say this. What causes motion? What causes motion is what? Force. force applied always brings about a change, and that change is always what? A motion aspect. So force causes what? Motion. But I'm not dealing with what causes motion. I just want to talk about what? The motions that we have in physics. And for your level, so we have translational motion, circular motion, oscillatory motion, random motion, and relative what? Motion. I come back again. Translational motion, circular motion, oscillatory motion, random motion, and relative what? Motion. Take note. Now, for each of them, we are going to be looking at it specifically. And we're going to be solving questions on it specifically. I may not be able to go run every one of them because it will look bulky. And I want everyone in this class to ensure that you are following. So I have to take it bit by bit. But I'll always appeal to you, every one of my students that are in the classroom, please ensure whatever point you are not getting very well, call back my attention. And mind you, if you don't ask me question, I will ask you question, because I want to know if you are really following. Because there will be a test, there will be an examination, and it will make me proud, not just you passing my own test or examination, but the ability to stand out and perform very well in your school or in your academics. I have my own goal as a teacher, that every student that I teach must be able to stand very well without any assistance, and not just being a student but also being a teacher. And what I mean a teacher, I'm not telling you to just go into the teaching field. What I meant is that you are able to teach other students. That is my target as a tutor. I want to ensure that all my students will be a student teacher. They will transit from just being a student to being a what? A student what? Teacher. They can transfer this knowledge to other of the what? Students. And that is not talking about being arrogant, because as a true student, you must be able to learn. So when there is a need to assist someone, you are able to give out this what? This knowledge. But you can't give out a knowledge if you don't know it. So you must have the knowledge first for you to give it out. Just as Cristiano or Messi, before they come to the field to play football, they have to practice. They give out what is in them. Are we there now? Albert Einstein gave out what was in him. So you as a student, you can only give out if it is in you. Just as what I'm teaching you now, it is in me, that's why I'm giving it out. So if you don't have anything, you can't give anything. So that is why you must sit down, learn this thing, catch this knowledge, so that you'll be able to what? Give it out. Okay. Now, translational motion. What is translational motion? We just listed the 5 types of motion. And we just said that motion is a change in what? Position. With what? With time. It's not happening in 0 time, but it's happening in what? In time. What is translational motion? Translational motion is a motion that takes place on a straight line. A motion that takes place on a what? On a straight line. I come back again. Translational motion is a motion that takes place on a what? On a straight line. It can be called linear motion. It can be called what? Linear motion. There's a motion that happens on a what? On a straight line. If I have someone here, let's say this is John. John, and John moved from point A to point B. Are we there? John moved from point A to point B. On a straight line, you will say John has what? Translated. This motion takes place on a what? On a straight line. Or you can call it rectilinear motion, because rectilinear is anything that happens on a what? On a straight line. Okay? So a car driving on a straight line is a what? Is translating. So you walk to school by translating. You come back from school to your home by what? Translating. You do the things, you move around by what? Translating. You move from your kitchen to your room, you translated. You move from your room to your bedroom, from your bedroom to your parlor, you translated. Are we together now? You see this everywhere you go. You just see that physics is around you. Physics is around you. So you move from your parlor to your room, you are translated. It's a straight line motion. Are we together now? Now, okay, now let's talk about circular motion. What is circular motion? Circular motion, as I said, is a type of motion that takes place around a circle. Circular motion is a kind of motion that takes place around a what? A circle, a curved path. We can call it a curved path, a circular path, a circular path. Example of circular motion: the earth is orbiting around the what? Sun. The moon is orbiting around the what? The earth. Other planet bodies are what? Orbiting around the what? The sun. So that is a what? A circular path. A car going around a circular path. We call that kind of motion circular what? Motion. But sometimes we always have what we call circular motion and rotational motion, like your fan, the fan blade that is going around. Are we there now? Or the wheel of a car tire that is going around. All is an example of what? Circular what? Motion. A circular motion. Other example, a circular motion. But we're going to be treating circular motion separately. We're going to look at everything that pertains to what? Circular motion. Now let's talk about oscillatory motion. Oscillatory motion is a to and flow motion. A to and flow motion. We can call it vibrating motion. A to and flow motion. When an object goes up and returns back, we say that object undergoes what we call a circular, a oscillatory motion, or we can say a vibrating motion. Is a repetitive motion that repeats itself. I can give examples. Some of your doors, it goes up, it comes back. Anything that repeats itself, or probably you have a curtain at home. All these are examples of what? Oscillatory motion. Or I can use this textbook. Just look at what I'm going to do now. Look at what I'm going to do. If I have this textbook at one hand and I flip it like this, What kind of motion is this? Oscillatory what? Motion. It's not something that is very difficult. You can take your own textbook, just do it like this. Oscillatory motion. Can't you say it's repeating itself? It's going to and it's coming back. Are we there now? Okay. Now, oscillatory motion, we can say vibratory what? Motion. Are we together now? Vibratory what? Motion. Then we talk about random motion. Random motion, this is a type of motion that goes zigzag. It's a zigzag motion. Zigzag motion. Like the dust particle. Example, the dust particle. All these are zigzag motion. The motion is not coordinated. It is scattered. When you carry a sand and you fling it up, what happens? The motion is zigzag, not coordinated. These are what we'll be looking at when we're dealing with particle nature of matter. We talk about osmosis, we talk about diffusion, we talk about some of all this kinetic molecular theory. We found out that some of all these particles, like the gas, when you allow the gas molecules to move, they move zigzagly. Some of them are not coordinated. That is when we'll be treating more about random motion. Then what about relative motion? In this type of motion, as I said to you, I'm going to be dealing with them specifically as we journey through the class. In this type of motion, there's a type of motion that has what we call a reference point. A reference point. For example, I say John moved from point A to point B. It simply means John at point B, his reference point will be point A. So in relative motion, there's a point of what? Reference. There's a point of what? Reference. You walk from your parlor to your veranda, or you walk from your parlor to your bedroom, and they ask you, where are you coming from? You say, I'm coming from the parlor or the sitting room. That simply means that point is your what? Is a point of what? Reference. Is a point of what? Reference. Now quickly, I will now touch what we call translational motion. That I will be dealing with today. I'm going to take a little portion of it while we journey in the class. If you have any question, please, you just raise up your hand and let's just continue thereby. Okay. So, translational motion. Are we together? Are we flowing? So let's go on. So let's look at translational motion. So let's look at translational motion. Translational motion. I'm just going to look at the parameters that will be encountering in this motion. So we all look at parameters you're going to be meeting in this motion. Parameters. What is a parameters of motion? Parameters of motion. So we have, I'm going to take what we call position. Position. I have distance. We have distance. So let's discuss this. What is position? Position is locating a space, a point in a space. Position is locating a what? A point in a space. So for example, you are position and position. This board is position. Your house is position in a space. Ability to locate a point in a what? In a space. And one of the systems we use to locate a point in a space is what we call the Cartesian system. We use the word the Cartesian system. Cartesian or rectangular system. Cartesian or rectangular system. Rectangular system. We'll take it bit by bit. Cartesian or rectangular system. And this we have what we call the vertical and the what? Horizontal. Let me just show you something. The vertical and the what? Horizontal. In locating a point in a space, how can I locate it? For example, they give me the point of John. They say point John have 2, 3. They give me B is equals to I have 4 minus 5. Minus 5. Now, in Cartesian system, we have the vertical and what? Horizontal. Vertical, take note. Vertical and what? Horizontal. We can use it to locate a point in a space. All these are parameters of motion. Now, we have the point of origin. We call it the point of what? Origin. The point of origin. The point of what? Origin. And now you're going to number it. To the right, we call it the positive. To the left, we call it the negative. That's horizontal. Then when it goes upward, we call it the positive. And when it comes downward, we call it the what? Negative. So we can say 1.1, 2, 3, 4, 5. That is taking your scale. Then we come here 1, 2, 3, 4, 5. Then this will be negative. Minus 1, minus 2, minus 3, minus 4, minus 5. Remember this minus x. This positive y, positive x. Then we have minus 1, minus 2, minus 3, minus 4, minus 5. Are we there? Now remember point A, they say you have locate this point. Position it. And I give me, they say when A is 2, y, A is 2 and 3. And B is what? 4 and minus 5. What I'm going to do, I will come up here. I will call this x. I will call this my y. I will call this x. I will call this my y. So let's position A. Let's position A. So x here is 2. So you come up here, you take it. Then they say y was 3, positive 3. Look at it, positive 3. So I'll come up here and I will trace it. And I will trace it. Where the meet becomes the position for what? A. Have you seen it now? I've used the Cartesian system to position what? A. I've used the Cartesian system to position what? A. Now what about B? B, they say x is 4. Are you seeing it? And y is what? Minus 5. You put it down, you trace it. You trace it. You trace it. At the point they meet, that is what? You have positioned what? B. You have positioned what? B. Now we're going to be dealing with that more often as we journey down the line. But mind you, you use the positioning to what? To Cartesian system to locate what? These 2 points. We have given them a position. This is the position for A. This is the position for what? B. This is the position for A. This is the position of what? B. I come back again. In Cartesian system, in locating a point in a space, position means locating a point in a space. And we have three types of way for your level at the beginner point to deal with locating a point, positioning a point. How? We have what we call the Cartesian system, the spherical system, and the cylindrical system. I'm just showing you one because I'm not dealing with position for today, but I just want to look at the parameters of motion. Parameters will be meeting for translational motion. Parameters will be meeting for circular motions. All these are connecting what? Parameters. So we have the Cartesian system or the rectangular system. We have point A, we located what? Point B. Vertical and what? Horizontal in locating a point under what? Cartesian what? System. And for the horizontal and vertical, you have the positive horizontal, and negative horizontal. Positive vertical and what? Negative what? Vertical. Remember, they have a point of what? Origin, and you numbered it. And this is how you did point A, you are able to locate it. When x is 2, y is 3. Positive 3 and positive 2. Where they meet, we give you the position for A. When x is 4, y is what? Minus 5. Where they meet, they give you the position for what? For B. Are we together now? So position under the parameter of motion is locating a point in a what? In a space. Are we there? Now, we look at distant. What is distant? Distant locating a point in a space. Now, what is distant? This is the interval between 2 points. This is the interval between 2 points. 2 points. Okay? Are we there now? Now, the interval between 2 points. Your room, your house, and your school are 2 positions. The interval between them gives us what? Distance. And distance is measured, it is measured in meters. It is measured in what? Meters. It is measured in meters. Now, point 3, we have displacement. Displacement. What is displacement? Displacement, this is the distance moved in a specific direction. Displacement is the distance moved in a specific what? Direction. Displacement is a distance move. If, for example, we say John walked 5 meters away, or John walked 5 meters, that you are just giving us the distance, but you are not giving us the direction. So, but when you say John walked 5 meters north, that you have added the distance he covered, and you have also given us the what? The direction. At that point, you say that what? He has displaced. That is displacement. Displacement. Take note. So we have something like this. You can say 30 meters north. This is how it is. Or you can put 30 meters, kilometers northeast. Not what? East. All these are examples of how displacement is being measured. Then the fourth one I'm going to look at is velocity. What is velocity? Okay, sorry. Let me look at speed. 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 This is the distance covered in a unit time. This is a distance covered in a what? In a unit time. It determines how far a car or how slow a car is moving. So if, for example, John and Angela traveled to, let me say, from one point to the other, or let me say, travel to Ghana, from Nigeria to Ghana, or from Mexico to what? United States. Then you can say, John, or let me say John from Mexico to United States, let me say it takes 50 kilometers. 50 kilometers from US to where? To Mexico. 50 kilometers. Let me say it takes 50 kilometers. Or we can say from Nigeria to Ghana. To Ghana, it takes 30 kilometers. And John with Angela traveled from US to Mexico, and John took about 30 minutes to get here, and Angela took about 50 minutes to get. They moved at the same time. Who will you say move faster? You say it's John. So John had more speed than what? Angela, because they covered the same kilometer. Why do you say that John moved more faster? Because he covered it in a very smaller time. So speed determines if a body is moving too fast or too what? Slow. Or if John traveled from Nigeria to Ghana and John used, let me say, 20 minutes, and Angela used 2 hours. Who do you say traveled faster? You say it's John. Why? Because he covered that distance in a short time. Now take note, speed and velocity are used interchangeably in translational motion. Speed and velocity are used what? Interchangeably. If, for example, because speed is measured in 20 kilometer, or let me say, yes, 20 kilometer per hour. I can have this as 20, mind you, kilo is 1,000, times 1,000, over this hour here, in seconds, is what? 3,600. Are we there now? You can convert it to become your what? In minutes, per minute. Now when you divide this, and you divide it, you have 27.7 meter per what? Seconds. So speed and velocity are used what? Interchangeably. So please take note of that. Take note of that. Remember, we are just trying to go around the parameters. So when I hear position, distance, displacement, speed, and let me just look at the other two. Velocity. Velocity, this is the change in displacement with respect to time taken. It is also measured in meter per what? Seconds. So velocity is a change of displacement with respect to what? Time taken. Remember, parameters of motions that will always meet. Parameters of what? Motions. Then acceleration. We look at acceleration. Acceleration. This is the change in velocity with respect to time taken. It is measured in meter per second square. It is measured in what? Meter per what? Seconds square. So take note, position, distance, displacement, speed, velocity is a change of displacement with respect to time, Acceleration is a change of velocity with respect to time. So when you are ascending, is that you are ascending or you are descending. In descending, there is negative what? Acceleration. We have a long way to go, but we're going to be taking it bit by bit. Because when we're talking about acceleration, we also look at deceleration, which is descending. Take note. In velocity, we're going to look at initial velocity and what? Final velocity. But why am I bringing this? So as you can be able to know the parameters that belong to what? Motion. Remember, physics is filled with so many quantities. So when I hear the word displacement, I hear the word velocity, I hear the word speed, I hear the word acceleration, deceleration, I know that they are navigating me into what? Motion. At any point, I meet it. Are we there now? So I want to bring this class to a close. Before I bring the class to a close, remember you must always ask me questions. Because through those questions, I will know if you are following me. And mind you, you are permitted to make mistake. Because mistake is part of the training. If you don't make mistake, I will not be happy. I want you to make mistakes so I will correct you. Because in this classroom, you make mistake for me to correct you and prepare you. But I will not want you to make mistake out there. But in my classroom, you are permitted to make the mistake. Ask the question. If I ask you a question, you're unable to answer me, I'll put you right. Are we there now? So at this point, I want to call the class. I want to bring the class to a close. Remember, chat me up, send me your questions. I will answer you personally or will answer you generally, however you want it. Are we there now? So let's just bring the class to a close. So in our next class, we'll look at the other face of it. Okay, John, Andrew, and all of you that is in the class, goodbye for now. Remember, you can also catch this video on your YouTube page. God bless you. See you there.